3, negative 6, 12, negative 24. That is our sequence of numbers that we're looking at. And if there is a pattern here, we want to try to continue that pattern for 3 more terms. That's what it asks, the 3 terms in the sequence after the last one given. So we got to determine what the pattern is. Okay, we're going from a positive to a negative to a positive to a negative. How is that even possible? We'll try to find out. If I wanted to check to see if it was arithmetic, I would do 3. What do I add or subtract from 3 to get to negative 6? It would be negative 9. But if I tried to do that again, I would get to negative 15. I wouldn't get to 12. So I'm going to try to see if there is a ratio. Term 2 divided by term 1. It's negative 6 divided by 3, which is negative 2. Let's try that one. If I multiply by negative 2, I do get to negative 6. I multiply by negative 2 again. Negative 6 times negative 2 is a positive 12. So you see that if your ratio is negative, that you will alternate between positive and negative numbers. And if we continue to do this and follow this pattern, times negative 2 would get us to a positive 48, then a negative 96, and then a positive 192. So next 3 terms, done. Now we want to find the term named in the problem. Oh, also this is geometric. I said it, didn't write it, but it's geometric. Well, now we want to find term 11. And we have been using this equation to determine any term. 0th term times r to the nth power. So term 11 would be term 0 times negative 2 to the 11th power. So what is term 0? I need to go backwards from here. Instead of multiplying 3 by negative 2, I want to divide 3 by negative 2. Okay, I'm doing the opposite because I'm going backwards. When I do that, I get negative 1.5 or negative 3 halves, whichever way you want to write it. Okay, so here is my explicit, well, let's say, I'll do this. Negative 1.5 times negative 2 to the nth. Okay, this is the explicit formula. And then here I have plugged in a specific term number that we are trying to find, term 11. We'll go back to the old calculator. We got negative 1.5 times, I'm going to put a negative in the parentheses here, raise it to the 11th power. And the reason I do that is because the calculator doesn't know to raise that negative to the 11th power also. It's just going to raise 2 to the 11th power without the parenthesis and then make it negative at the end. I want it to know that I want negative 2 times negative 2 times negative 2, not just a positive 2 over and over again. When you do that, you get 3072. So term 11 is 3072. If you wanted to, you could. So this is 1, 2, 3, 4, 5, 6. This is the 7th term. To get to 11, it's not too far. 192 times negative 2. That's the 8th term. There's the 9th term. There's the 10th term. And there's the 11th term. Okay, but not too bad to get there, just using a recursive definition. And you are welcome to do that. If you would like to, check your answer, make sure that your formula is correct, then go ahead and do that. And I'll catch you on number 6.